Hoping.
But I know in our other class we just watched along. But we also had like 4 people in that class.
Yeah. All right, here we go. Opposite angle identities is what this is called. Speaking of, on the back of your paper, on the back of your unit circle, we're going to fill in this top right spot that says, call it opposite angle identities. I'm going to fit 6 little formulas in there, so don't write opposite angle identities in half the
Can you
space.
let me one too? Yeah.
Okay. So we're going to go over this nice and slow. I'm going to try to help you understand it, although it's going to be a little tough. All right. Are you ready? What is the cosine of 30 degrees?
3 squared over 2.
The square root of 3 over 2. Everybody understand that? Is everybody good with this? Okay. What is the cosine of negative 30 degrees?
Negative 3 squared over negative 2.
Where'd you get the negative 2?
Negative 3 squared over 2.
Where did you get the negative square root of 3 over 2?
You said we had. You said negative 30.
It's
Nope. Talk to your team.
How is it that? Because.
Look at Alondra.
So negative 30 degrees, it's just to go down degrees to
Yep. Talk to your partner right now. Show them where negative 30 degrees is. Okay. Are we all on the same page? So, are we all aware that the cosine of 30 degrees is the square root of 3 over 2? And the cosine of negative 30 degrees is also the square root of 3 over 2? They're the same thing, right? Good. So on the back, I want you to write the cosine of negative theta is equal to the cosine of theta. Notice I'm taking up only half this box because I'm going to write something next to it. Cosine of negative theta is equal to the cosine of theta. What that means is that the cosine of 30 degrees is the same thing as the cosine of negative 30 degrees, and that will always be the case. Okay, and the only reason that that works is because we're talking about the x, right? The x value right here, which is the same for both. Do you remember what other trig function only has to do with x? Cosecant, because cosecant down here, well, not cosecant, secant. Secant, because down here it says secant is 1 over x. So the secant thing is the exact same thing as well. I'm going to write it right next to it. The secant of negative theta is the same thing as the secant of theta. Okay, now let's look at sine. What's the sine of 30 degrees? 1/2. Everybody, show your partner right now. Point your finger to the sine of 30 degrees. Point your finger at the sine of 30 degrees. Everybody pointing at the y value right now? Okay, now show your partner. Point your finger at the sine of negative 30 degrees. Negative 1/2. Does it make sense to you guys that since we're going from the top half to the bottom half, we're talking about y's, that one of them will be positive and one will be negative? Okay, so here's how you write it. You say the sine of negative theta is equal to negative the sine of theta, which means that whatever the sine of negative 30 degrees is, it's the opposite of the sine of 30 degrees. They got opposite signs. How about, what's the other thing that has y in it? Cosecant has the exact same rule. Cosecant of negative theta is the same thing as negative cosecant of theta. Okay, now we got tangent to think about, right? Tangent is y over x, and on 30 degrees, both y and x are positive, right? But down here, at negative 30 degrees, one of them's negative and one of them's positive. So will they be the same as each other or opposites of each other? Opposites. So I'm going to write that one down here, that the tangent of negative theta is equal to negative tangent theta. That means if one of them is 1/2, the other's negative 1/2. If one of them's positive 2, the other one's negative 2. And the same thing with cotangent. Because cotangent is just x divided by y. So today we're just going to practice a little using the Pythagorean identities, these ones right here that we haven't used in a little while, but also using the opposite angle identities. And we're only going to do like half of what I was planning to do before. Which is a total of 3 problems. So let's do it. Example 1. If tangent of theta is negative 5/3, I want you to find secant of theta. Sorry, we're back to purple. I really regret this green decision that I made. I believe Tegan technically made this decision.
What?
Yeah, I think, were you the one who decided bright green for the unit circles?
Yeah.
I encouraged it though. Now, you cannot just say when you're doing tangent that since tangent is y over x, that the y is 5 and the x is 3. You can't do something like that because this is reduced, so we don't know what it was before. So we have to use a Pythagorean identity. So flip your unit circle over, look at the back side. Which one do you think we should use? The second one says tangent squared theta plus 1 equals secant